To determine the appropriate size for service conductors, different procedures are used for residential and commercial applications. For residential applications, Table 310.15b6 of the National Electrical Code is used to determine the conductor size. However, for commercial applications, the process involves several steps to ensure proper sizing and compliance with the electrical code. Firstly, it's crucial to determine the correct temperature column to use in Table 310.16. This selection is based on the lowest temperature rating of any connected termination, conductor, or device, as outlined in Section 110.14c of the NEC. The temperature rating associated with the ampacity of a conductor must be selected and coordinated so as not to exceed the lowest temperature rating of any connected termination, conductor, or device. Most electrical inspectors recognize that the lowest rated, or weakest link in the chain, is almost always the lug. Lugs for number 1 and smaller wire are typically lab rated for 60 degrees Celsius, unless otherwise labeled. Lugs for number 1/0 and larger wire are generally lab rated for 75 degrees Celsius, unless specifically labeled. Once the appropriate temperature column in Table 310.16 has been identified, the next step is to choose the correct conductor size from that column. This selection is based on both the overcurrent device rating and the conductor ampacity. Section 240.4b of the NEC, titled Devices Rated 800 amps or less, allows for the use of the next highest standard overcurrent device rating above the ampacity of the conductors being protected, provided certain conditions are met. Firstly, the ampacity of the conductors must not correspond with the standard ampere rating of a fuse or circuit breaker. Secondly, 240.6 lists the standard ratings for 800 amps or less as 1, 3, 6, 10, 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80, 90, 100, 110, 125, 150, 175, 200, 225, 250, 300, 350, 400, 450, 500, 600, 601, 700, and 800. To illustrate, a 90 amp limit taken from Table 310.16 would necessitate a 90 amp or smaller breaker. Conversely, a 91 amp limit taken from Table 310.16 would require a 100 amp or smaller breaker. Let's consider a few specific examples. For a 100 amp service, a wire rated for 91 amps or larger, as determined from Table 310.16, is required. For number 1 or smaller wire, refer to the 60 degrees Celsius column. It's important to note that even if the wire is rated for 90 degrees Celsius, the column dictated by the lug rating must be adhered to. In this case, a number 2 conductor is needed. The number 4 conductor that might be obtained from Table 310.15b6 is not applicable here because it's the wrong table for commercial applications. For a 150 amp service, a wire rated for 126 amps or larger from Table 310.16 is necessary. For number 1/0 or larger, the 75 degrees Celsius column should be consulted. A number 1/0 conductor is required in this scenario. Using a number 1 conductor from Table 310.16 column 75 degrees Celsius is incorrect because it's the wrong column for lugs connected to number 1 wire. Similarly, a number 1 conductor from Table 310.15b6 cannot be used because it is the incorrect table for this application. For a 200 amp service, a wire rated for 176 amps or larger, as per Table 310.16, is needed. For number 1/0 or larger, refer to the 75 degrees Celsius column. In this case, a number 3/0 conductor is required. The number 2/0 conductor obtained from Table 310.15b6 should not be used because it is the incorrect table. In summary, for residential applications, use Table 310.15b6 to determine the conductor size. For commercial applications, firstly determine the correct temperature column in Table 310.16 based on the lowest temperature rating of connected terminations. Secondly, choose the conductor size from the appropriate column based on the overcurrent device rating and conductor ampacity. Thirdly, use standard overcurrent device ratings as specified in 240.6a. Fourthly, ensure that the conductor ampacity does not exceed the standard device rating as per 240.4b. These examples highlight the differences in conductor sizing between the tables. A 100 amp service requires a number 2 conductor from table 310.16 using the 60 degrees Celsius column, while table 310.15b6 would incorrectly suggest a number 4 conductor. A 150 amp service needs a number 1/0 conductor from table 310.16 using the 75 degrees Celsius column, while table 310.15b6 would incorrectly suggest a number 1 conductor, and table 310.16 using the 60 degrees Celsius column would incorrectly suggest a number 1 conductor as well. For a 200 amp service, a number 3/0 conductor from table 310.16 using the 75 degrees Celsius column is needed, while table 310.15b6 would incorrectly suggest a number 2/0 conductor.